In this video, we are going to see about op-amp with negative feedback. So in that, we will see about the inverting operational amplifier. There are two different configurations for op-amp. You can operate in either open loop mode or in closed loop mode. In open loop mode, we have two input terminals. So you give some input to the input terminals and you will get the output. So this is open loop configuration. So here you cannot change anything. So output depends upon the input. Here in closed loop, a part of the output is fed back to the input. So you take a portion of the output and give it to the input. So here you can control the gain. So in open loop configuration, we normally give the input to the two input terminals and the op-amp will amplify the difference between the voltages applied to the terminals. So V0 is given by A into Vd, where A is the open loop voltage gain of this operational amplifier. So this A value will be equal to 10 power 5 or 10 power 6 depending upon the op-amp we choose. For example, if A is equal to 10 power 5 and Vd is normally a small value because it is only the difference of these two. So V0 will be a very high value. We know the transfer characteristics of a op-amp. So this is x-axis, you have the differential voltage Vd, and in y-axis we have the Vout or output voltage. So you can see here only for this particular portion the curve is linear, after that it saturates. So the saturation voltage depends upon the power supply we give. Normally it is 15 volts. So since A is a very high gain, normally when you operate the op-amp in open loop mode, it will be in plus Vsat or minus Vsat. The output is always plus or minus Vsat. So this has very limited application. That is, the op-amp in open loop mode has very limited applications. Take this voltage comparator which is connected in an open loop mode. You can see here the op-amp, there is no feedback in this, so it is in open loop mode. Here this type of circuit is normally used to check a battery level voltage. That is, when the battery voltage falls below a certain value, one LED will glow, otherwise the other LED will glow. So for these type of circuits, we can use the op-amp in open loop mode where the output will be always plus Vsat or minus Vsat. So it can be like that. But in most applications, we need to operate the op-amp in this linear region so that we can have a control over the output. So for that, we need to go for a closed loop configuration. So in closed loop configuration, you are taking a part of the output and giving back to the input. By this way, we are able to operate the op-amp in this linear region. So this part you can operate it. Now there is a confusion where the output part, why it is given to the negative side, why can't be given to the positive side. You can give the output to both the negative pin or to the positive pin also. If you give it to the positive pin, it is called for positive feedback, and if you give it to the negative pin, as it is shown in this circuit, it is called negative feedback. In electronics or in op-amp applications, mostly we will be using negative feedback because it is stable. Positive feedback, actually it may lead to instability in some conditions. So normally negative feedback is preferred and it has more applications. For op-amp with negative feedback, there are two important applications. One is the inverting amplifier and the other one is the non-inverting amplifier. In inverting amplifier, the input, here V2 is the input, is connected to the inverting pin, inverting input pin, minus pin, through a resistor R1, and the output is fed back to the input through a resistor, feedback resistor RF, and the non-inverting input pin is connected to the ground. So this is the inverting amplifier, and we will see the operation of this amplifier in this video. Next, we will see about non-inverting amplifier. So here you can see the input voltage V1 is connected to the non-inverting pin plus. Okay, in this case it will be connected to ground, whereas here we are giving the input signal to this pin, and the negative pin is connected to the ground through a resistor here, just opposite of this one. So you have to remember, in inverting amplifier, input should be connected to the inverting pin. In non-inverting amplifier, the input is connected to the plus pin or non-inverting pin. The remaining circuit remains the same. So here the other input should be grounded. Here the negative pin should be grounded. For an op-amp with negative feedback, there are two golden rules to be followed. So without knowing this rule, you cannot solve or you cannot design any circuit using op-amp. Okay. So you should know about these two golden rules. So this one is an inverting amplifier I have taken. Now we will see what are those two golden rules. Let us mark this node as N. So the first rule is that the current drawn by the input terminals is 0. So this we have studied in the ideal characteristics of op-amp. So the op-amp will not draw any current from the source. So here in this op-amp, no current will enter the op-amp. We have an input here. So from here current will be there. No current will enter here means all this current will flow. So whatever current is flowing through R1 will flow through RF also, because no current is going to enter here. So the current drawn by the input terminals is always 0. So the next rule is that the differential voltage, that is the difference between the two input terminals, is essentially 0. So you should not take this point. Between these 2 points, it is 0. Why do we say that? We know open loop gain is infinite, or at least a very high value. So if this should be infinite, what is the output voltage? V0 is equal to A into Vd. So if A is infinite, or we can write A is equal to V0 by Vd. If A is infinite means Vd is 0. If Vd is 0, in this case we have connected V1 to 0. V1 is ground, so it is 0. So when Vd will be 0, only if V2 is 0, Vd can be 0. So always this differential voltage will be very small, or it will be essentially 0. So this is the second golden rule. Here you have to know about one technical term called virtual ground in op-amp. What does that means? This point is called virtual ground. So we saw in the second rule is that Vd should be 0. This point is connected to ground. So this point, if it is 0 means it is virtually connected to ground. Physically it is not connected to ground, but this is ground means this point should also be, or this node should also be ground. So this is called virtual ground. It is not physically connected to ground, but it has the ground potential, so it is called virtual ground. So knowing these things, we can see the inverting amplifier. So in inverting amplifier, the input is given to the inverting input through the resistor R1, and the non-inverting input is connected to the ground. Now we have to derive a relation between the output and the input. We know two golden rules are there. Let us apply that and derive this relation. So the first rule is that no current enters the op-amp. That is, the op-amp will not draw any current. So whatever current, this I1 flowing through R1 is equal to the current flowing through RF, because no current is going to enter here. So using this rule, let us write the nodal equation. So let us take this node n. So at this node n, write the nodal equation. Vn minus V2 divided by R1 plus Vn minus V0 divided by Rf is equal to 0. Okay. So now we know what is Vn. Vn is this voltage V1, which is equal to 0 because this is the virtual ground here. So Vn is equal to 0. Let us make Vn equal to 0 in this equation. So you will get the relation between output and input. So the closed loop gain of the inverting amplifier is given by V0 by V2 is equal to minus Rf by R1. That is negative of feedback resistance by R1. So by changing this ratio, that is Rf and R1, you can change the gain of the op amp. Now here we have a negative sign. So this negative sign indicates that the output will be 180 degree out of phase with the input. For example, if V2 is a sine wave like this, the output it will be like this. That is, the output will be 180 degree out of phase with the input. So here you have a positive half cycle. Here you will get the negative half cycle because output is 180 degree out of phase. So let us summarize what we have seen here. Op amps can be operated in either open loop mode or closed loop mode. Open loop configuration has limited application because the output can vary between plus Vsat and minus Vsat. Op amp in closed loop configuration, there are two major applications. One is the inverting amplifier and the other one is the non-inverting amplifier. In this video, we have seen about the inverting amplifier. In inverting amplifier, the input voltage is given to the inverting input of the op amp and the non-inverting input is connected to the ground. And the closed loop gain of the non-inverting amplifier is minus Rf by R1, that is the minus of feedback resistor divided by input resistor. So by varying this ratio, you can vary the gain of this op amp. In this inverting mode, the output will be 180 degree out of phase with the input. If you like the video, do subscribe to Read Electric Vehicle channel and share it with your friends. Thank you.